Let's trace this program called ArrayAsAProperty demo. We have a client program and we have a class called student. Right here is the class called student. And the class called student has instance variables, also known as properties, my name and my schedule. My name is a string and my schedule is an array of strings. You could think of the schedule being sort of like chem during the first period of the day, history during the second period, calc third period, and so on. So let's start tracing. Let's start tracing the client program. Here we go. At the beginning of the program, we have an object variable named stud1. So stud1 is given a memory address, an object reference. Let's just pretend it's the memory address A32. And at the memory address A32, we have room for a student object to be instantiated. So reminder, the right-hand side of the equal symbol here is called instantiation, and the left-hand side is called declaration. We've declared stud1 as a student object reference, and A32 is the memory location of where the actual object exists in the memory of the computer. So now let's go look for this default constructor in the student class. Let's find that. Here it is. Here's the default constructor in the student class, public student. So let's execute this line, this code. My schedule is equal to a new string. We could have done just my schedule equals new. No, we couldn't have. That's just a line of code that instantiates an array of strings of length 5. And in position 0, we have the word chem. In position 1, we have the string history, and so on. So we are instantiating the student's actual schedule in the default constructor. Hey, what's the name of this student? While we're at it, what's the name? Well, the default constructor isn't specifying that my name equals John or something like that. So I guess my name is equal to null string, also known as empty string. So let's reflect that back here next to our client program. My name is currently equal to the empty string, two quotes next to each other is the way I represent that. And my schedule is an array of strings of length 5. So I filled in the initial strings that are stored in the 5 elements of the property instance variable known as my schedule. So this is stud1. Stud1 is an object variable that points to this object in the memory of the computer. Now, let's execute this for loop. The local variable I is currently equal to 0, and I is going to iterate in plus plus until I is less than, or while I is less than stud1.schedule.length. What? Let's track this down. This is pretty complicated. Stud1 is this mess. Stud1.getSchedule. Well, what does getSchedule do? GetSchedule is an accessor method. It's an accessor method that returns an array of strings, and it returns the array mySchedule. So the array mySchedule is this right here, and if we dot length it, its length is 5. So really, all of this complicated syntax here simplifies to the simple number 5. We cannot type mySchedule.length because mySchedule is private. Notice, like all properties in classes for good style, you should always make them private. So therefore, if mySchedule is attempted to be used over here in the main method, it would be a compile error because it's private. So we have to do stud1.getSchedule.length. Of course, we could break it down into extra little variables, but this works and this is quite fine. So it's number 5. Now, let's execute this line of code. stud1.getSchedule simplifies to this array. We're taking this array and we're plugging it into schedule. So I'm going to reflect that by making a local variable in the main method named schedule. It's an array variable, and it has a length of 5, and it has positions 0 through 4, of course, and it's simply a copy of this array that's part of my name. So it looks something like this on our scratch paper if we were to represent it on paper. So this is the variable, the local variable schedule, and this is my schedule, which is part of the object that's pointed to by stud1. Let's not confuse them. Next line of code, course equals schedule square brackets I. Well, I is currently 0, and therefore chem is what string is currently stored in schedule I. So the word chem is being passed into this new variable that we're declaring named course, and the string literal chem is being assigned into the variable course. The next line of code, system out print course. Well, that's easy. We're printing out the word chem. So our printout at this point on the output display, just the word chem shows up. And because it's println, the blinking cursor moves down to the next line, awaiting the next piece of output. Well, the loop iterates and goes back up to the top of this for loop. It comes in from the right side in I++s. And we check to see if I is less than 5. Yes, 1 is less than 5. So we execute this line of code again. Well, this is very inefficient. I'm pointing that out here. We're taking this complete copy of this array and we're again dumping it into this local variable. We could have moved this line of code above the for loop so it only executes one time, but it's written this way, so let's just trace the code this way. The next more important line of code is what happens here. Course equals schedule I. Because I is currently 1, we are coming here to schedule and we're finding the string that's in position 1, which is history, and the word history is being assigned into the variable course. And a split second later, the program system out prints course, so it system out prints history on a new line. We hit the end of the for loop, which means we iterate back up to the top. We I++. We go through this again. At this point, schedule I is calc. So calc gets temporarily stored into the local variable course, and therefore calc prints out. I++ is to 3, which causes English to be stored in here. And that, of course, leads to the word English being printed out in our output. And finally, I++ is again and reaching 4, and that causes the word Java to overwrite English, and therefore Java displays in our console output window. Just for the record, I++ is in increments to 5, at which point the code yields a false because 5 is not less than 5, and this loop is finished, and the computer comes down to this line of code to execute. I'm going to clean up my display here. So having cleaned up our display, we are ready to execute the code that occurs right here. We are declaring another array of strings named newSchedule. I guess we could have reused the array schedule, but we're not. We're naming something new schedule. It's an array of strings, and this is a legal way to instantiate an array. You can just use curly braces and plug in the strings separated by commas. This is interesting because the length of new schedule is 6, whereas we were working with arrays that were length 5. Make a note of that. Well, we now execute the code stud1.makeNewSchedule. This is a method, and stud1 is a student object. So we have to go to the student class to find out what the method makeNewSchedule does. And make a note that this array, newSched, is being passed. It's an actual parameter. It's being passed to some matching formal parameter in the makeNewSchedule method of the student class. Let's go find it. Oh, here it is. MakeNewSchedule is what Minnick calls an interesting method in the student class. So the parameter up above, the actual parameter, newSched, is being passed to and matching up with the formal parameter, newSchedule. That's fine. They don't have to have the same name. So newSchedule is an array of length 6, and it stores the same values as the array did, as the array newSched did up in the client program. I'm not going to take the time to fill in those words, but notice what happens. This array overwrites my schedule, and because we are in the student class, we do have access to the private property mySchedule. So this is legal. So this schedule, which I never took time to fill in, is overwriting my schedule. Let's reflect that here on this page with the client program. This schedule is overwriting this schedule. And I'm not going to take time to erase and rewrite my schedule in here. Let's just use an arrow, or better yet, let's just use this notation here, a double star, to show that this array has now been copied here, and it's also known as mySchedule. So it's sort of like the student went to the guidance counselor's office and got a new schedule. The courses that used to be in here, Chem, History, Calc, English, and Java, are massively replaced with this new schedule. And interestingly, the student now is taking more classes than he or she did before. Their schedule is 6 periods long, and their schedule used to be 5 periods long. Well, that's how it goes in this fictitious school. Okay, the next line of code that you should analyze with me. Stud1.changeSchedule, another interesting method that we have to go to the student class to execute. This time we have 2 actual parameters being passed, physics and the number 1. Let's go check it out. Here is that method, changeSchedule. New course, the parameter new course, is really physics, the string physics, and I believe it was the number 1 that was stored in, that was being passed as the other parameter. Therefore, the local parameter period is really the number 1. It's an int. Okay, executing this single line of code shouldn't be too hard. Physics is being assigned through this assignment statement from right to left. It's being assigned somewhere. Simplifying the arithmetic expression 1 minus 1, because period is 1, you see. That, of course, is 0. So we have a set of square brackets here around a 0, and preceded by mySchedule. So physics is overwriting whatever string is in the 0 position of mySchedule. Physics. Let's see what this student just did. This student just changed his or her schedule, but not the whole schedule, just Jim. Jim, which was in position 0, has now been overwritten with the string physics. And that's that. Now you could just analyze this code and believe the fact that it's very user-friendly. Even a guidance counselor that never studied Java could analyze this code. The student is now taking physics during period 1. But did you see why we subtracted 1? Because over here in this change schedule method in the student class, if we didn't put the -1 here, then physics would be going into period 1, the variable period. In other words, physics would have went into the place of bio. If we didn't subtract 1, then a guidance counselor would have to know to put the number 0 here if he or she wanted physics to be the student's first period of the day. And possibly the counselor would have to tell the student, okay, Joe, you have to go to physics during period 0. We would just be confusing people to tell a student like Joe, hey, go to physics during period 0. That would just be confusing. So to make this user-friendly, we subtracted 1 over there in the student class to make it work right. Moving on, we have this strange system out print. That just puts a blank line in our output. So below Java here that we had before, we are going to have more output show up on a full blank line. And what are we saying here in the comments? Displaying new schedule, same for loop as above, only without using extra temporary variables. See this for loop up here? The purpose of this for loop, as you see from its comment, was to display the original schedule. And it did that quite well. It displayed each course on a separate line. But look, it made use of this array of strings, which was kind of inefficient if you remember our discussion. But it also made use of the variable course that we were keeping track over here in the left column. Well, we could have consolidated these lines of code into one line of code. So let's see how this is done. We are going to be printing the student's current schedule, physics, bio, music, French, Latin, and art, right here in our output window. But check it out. The local variable I is initialized at 0. This code right here is 6 because stud1, which is an object variable storing the object reference A32, and therefore my schedule, which is this schedule here is really copied there. It has a length of 6. Positions 0 through 5, which means it has a position of 6. So all of that is just the number 6. And then we system out print something. Well, let's analyze this very closely. Stud1.getSchedule. That means we're looking at this schedule right here. And then square brackets I. Because stud1.getSchedule, that much of it, returns this array. Remember, we cannot write my schedule square brackets I. Even though we're trying to take the word physics out of this, we can't call this my schedule. My schedule is private in the student class. And in this client program here, we can't just directly refer to my name or my schedule. So a slick way to do that is to use the accessor method getSchedule and immediately put square brackets I after it. We don't need this extra local variable course if we really don't want to make use of it, because this is pulling the word physics out, and because we're now in a system out print statement, the word physics does print out something like this. Of course, the rest of it's easy. I++ is to 1, and all of this code pulls out the whole array, but because square brackets I is now square brackets 1, we're pulling out the word bio here from position 1, and I++ is to 2, and therefore we're pulling out the word music, and so on. You can trust me that it ends up printing out this whole schedule: French, Latin, and art. And eventually, just for the record, I++ is to 6. At which point, 6 is not less than 6. And because of the false that we get, this loop is finished and there's nothing left to do in this client program. Some odds and ends that I'd like to stress about this client program and its complementary class named student on the next page. Notice that we only ever had one object variable declared in this program, and there was only one object being instantiated in this program. Also notice that the getSchedule method in the student class returns an array of strings. You would not say that this method here returns a string. Because of the square brackets, it's proper to say that it returns an array of strings, or string square brackets. What's the formal parameter that's passed to newSched? newSched rather, the actual parameter newSched ends up being passed to the formal parameter newSchedule. That's an interesting thing that I stressed. What else should I stress? Well, it is a subjective choice as to whether you prefer this for loop for displaying the whole schedule, or this shorter for loop right here for displaying the whole schedule. If you were putting this code on an answer on the AP exam, they would give you full credit probably for either answer. Let's consider one other thing in this program. Let's say that we wanted a other constructor, not a default constructor, but what Minute calls an other constructor. Well, we would place it right here between these two things. And the other constructor would start like this: public student. But because by definition, something that's not a default constructor, it needs parameters. And let's say that we wanted two parameters. We wanted a string that could be passed in to represent the person's name. I'll just call it new name. It could be named anything. And we would also want a parameter that allows for a new schedule to be passed in. And let's just call that new schedule. It's an array of strings, of course, so you need the square brackets there. So that's string, square brackets, new schedule. Sorry about my sloppiness. Well, the other constructor would then take whatever new name is and assign it into the private instance variable, my name. And because assignment statements work from right to left, that would be the right way to write the code. This new name here would be assigned into my name. And we would also take this new schedule, which is an array of strings, and it would be assigned into my schedule. And that's that. Quite easy. That would be a other constructor that could be used in this program.